Hello again, everybody. Welcome to another video here on my YouTube channel. I'm very happy to have you back for this one, and I will do my best to provide some value here during the next minutes. What we are talking about today in this video of the series Reveal SAP EWM is one of the, let's say, biggest misconceptions from my perspective, from my experience in EWM, and this is about sorting of storage bins during the put-away process. And I will jump right away into the scenario we are talking about, just to avoid misunderstandings up front. We are talking about sorting of possible destination bins. We are trying to put away to an empty bin, or based on a strategy where we are adding to stock, so to a partially occupied bin. And what you can see here on the picture as an example is a rack where you have multiple different empty bins. And we now need to give EWM the information to decide which of the empty bins we want to fill first in order to optimize our put-away process. For example, in order to optimize the travel paths and the walking distances during put-away, or even to lay the groundwork here to optimize the travel distances later, also during picking and stock removal from the rack again. This might sound straightforward now, but there are, as I said, some spots for potential misunderstanding and misconceptions. So within this video, I am going to explain the standard logic. So how is EWM actually sorting here, and also sorting in other areas, and where I have seen the biggest misconceptions. I will also show you the configuration side. So in case you want to sort, or in case you are in a project or you have a task to sort storage bins for put away, I will show you where and how to do the configuration and the actual sorting then for your storage bins, so for your master data. As usual, we will have a look into the coding. I found some spots in the standard code which are a little bit confusing actually, but at the end of the day, you will have everything that you need also in case you need to debug the standard logic, standard sorting, etc. And as you know it from my videos, I will also give you the options for enhancing and implementing a custom logic here. With that, let us first have a look at the standard logic. So how is EWM sorting bins in general? And in order to understand that, it is very important to realize that there is never a bin sorting or an assignment of a sorting number without a context in EWM. You always assign sorting numbers along with an activity area and an activity type. For example, you might have an activity area consisting of, let's say, 3 pallet racks, and you have then the activity type picking, and then you sort the bins in this activity area for the activity type picking. Then you might have a different activity area with those 3 racks in addition to a mezzanine, and you want to sort for the activity internal processes or replenishment, and you can have a separate sorting number for this combination of activity area and activity. And this is important to understand up front. We have these combinations of activity area and activity area. So this is important to understand up front. We have the combination of activity area and activity, and for this combination we can sort the storage bins. As you define activity areas and activities in the customizing, and then sort the bins via transactions and reports offered via the easy access menu. You can also sort via an Excel upload. We will come to this later again. And once this sorting has been done, so sorting via the report that I just showed you or via the Excel upload template, you will have the sorting numbers, so these sort sequence numbers along with the activity and the activity area assigned to the storage bin in the database table, SEWM, LA, GPS. This is the base knowledge here up front. You need to understand that in order to understand everything else. So which activities do we actually have here? In total, it's 8 different activities that come along with the standard package of EWM. And you might now think, and this is the first misconception, and I have seen that over and over again, that people think that the activity type putaway, PTWY, is used to sort the storage bin during putaway, which is not the case. PTWY is used to sort the putaway warehouse task within warehouse orders. So once the putaway tasks are already created, these sequence numbers here for this activity are used to sort those already created tasks within warehouse orders during the warehouse order creation. It's not used to determine the most optimal bin for a given warehouse task in order to do the putaway. And for this purpose, EWM comes with the activity CLSP, which is cross-line stock putaway, and this is used to sort, or I would better say to prioritize possible destination bins, because EWM uses this to select 1 out of n possible destination bins. Remember the picture that I showed you on the first slide here for the destination of a given warehouse task. With that, you could think we are done. I know now, or you know now, which activity type is being used for the sorting of possible destination bins during putaway, but there are a lot of details left for you to take away from this video and to be revealed. We will do the code review. We will also look at how the sorting within the warehouse orders actually works later. So we are just starting here, and I would highly recommend to stay here for the next 10 to 15 minutes to gather this additional knowledge also.
Sorry to bother you one more time, and again, forgot to remind you about hitting the subscribe button. Please make sure to do so. It will motivate him to create further videos, and you'll be notified about any new releases.
So as mentioned before, I will give you everything you need to do the configuration. Let's start with that part. It's pretty easy. You have in total 3 nodes in the customizing that you need to touch. First of all, you need to define the activity areas. Then you need to assign the bins. So an activity area might be one storage type, it might be a part of a storage type, and it can also be multiple storage types combined together in one activity area. And with the assignment of the storage bins to the activity area, you define exactly that. In addition, you need to define the sort sequence for cross-line stock putaway. It's not mandatory to do anything here. If you don't define a specific sorting, standard will just sort based on the name of the storage bin. But you have and you can set up very sophisticated sort sequences here, which I will explain to you in the next minutes. First thing that you do here is to define whether you want to sort first based on the stack, level, or bin subdivision, and subsequently the second and third sequence criteria. I will have examples for this so that it becomes easier to understand, and I will also show you examples about what it means to sort an AL, stack, or level alternating, respectively not alternating. I need to be aware of the wording here that an AL is not necessarily a rack, and you might use the word rack for the word AL, but this is kind of abstracted here, yeah? So you need to align it to the way that your physical warehouse has assigned the AL to the physical racks. Yeah, for some of you, an AL might be both sides, like both racks on both sides when you stand in front of the physical AL. For some of you, it might be just one AL. And based on this, then you assign the numbers here. I hope that did not confuse you. Anyhow, let us have a look at the examples that will make it easier to understand for you for sure. This is the first one that I took where I thought it would be helpful for you. That is the example for sorting of ales in an alternating or non-alternating way. First of all, it's important to understand if you sort based on CLSP, EWM will always sort based on the ale as a first criteria. You see that here, the first value that is counting up is the one for the ale. Yeah, you see here the 021 stands for the storage type, and then digit number 4 and 5, here's the ale. And that will always count up for in case you sort based on CLSP. So the only thing that you can influence here based on the customizing is whether you want this to be alternating or not alternating. And if it's alternating, you see here that we are counting up. We have in total 10 ales here. And once we've reached the max value of 10 here, we are counting down from 10 again. So you need to imagine in this example here, we are walking along different ales, filling the first stack, here stack 01. And once we've reached the last ale number 10, and we have filled here the first level of the first stack in all ales, then we are walking back and we are filling the second stack of all ales. But we are starting with the last ale here, so with ale number 10, and then coming down back to ale number 1. And if we are doing this in a non-alternating way, we are reaching here ale number 10, and then we are coming back to ale number 1 to proceed with the sorting and the assignment of the next stack. Now this is the difference between alternating and non-alternating. And we do see the same also here in the examples that I took for the sorting based on the stack. And this one should also reflect the sequence between the different criteria that you can use for the sorting. So on this slide you see that it's first sorted based on the stack and then on the level, and on the next slide you see this vice versa. And if we are sorting based on the stack first, it means we are first here filling all stacks on a certain level. You see here the level stays the same. Here's the sequence number. We are filling all stacks. In this example, we are doing this in an alternating way, and you see we have a total of 20 stacks. So once we have reached the 20, we are again counting down the stack for the second level. And if we are doing this in a non-alternating way, you see here we have reached the 20 and we start from 1 again for the second level. And in the example where the level is the first criteria for sorting, you see here that we are counting up the level. We have up to 3 levels here. So we are first counting up the level for the same stack, and then we switch to the next stack. And in this alternating example, then counting down the level again. And here on the right side, in the non-alternating example, starting with 1 again. The idea of those screenshots, those 2 slides, were to first have you understand the prioritization between level, stack, and bin subdivision. For bin subdivision, I didn't give you examples, but it works in the same way here. And secondly, to highlight the term and the way this alternating versus non-alternating works. And third thing that is important to understand, that for the CLSP sorting, it's always sorting at first based on the ale. And that is what you should take away from here. And with that, we come to the actual sortings. So how do we now sort the bins based on the logic that we defined in customizing? And that again is pretty easy. You have 2 options. First one is transaction SCWM SPST. So you only have to give the activity area and the activity type. then based on what you defined in customizing, EWM will sort the storage bins. And the second option that is usually used in case what I just showed you in terms of standard sorting is still not sufficient to cover your requirements, you can make use of a Excel upload, respectively CSV upload, where you provide the combination of storage bins, activity types and activity area, along with some other data, and then you can assign random sort numbers based on whatever logic you might want to use for the bin sorting and upload it to EWM. At the end, both of them will fill the SCWM LAGPS table that I mentioned before. I will also link a note in the video description where you can get the Excel upload template in case you need it in your projects. One last point, something that I noticed where I would like to ask you whether you have an idea why we are actually saving the sort sequence number for the CLSP activity in table SCWM LAGP in addition to LAGPS. Now, for all other activities and the sort sequence numbers, including CLSP, we are saving the data in SCWM LAGPS table, and for the CLSP sorting, we are filling this also in the LAGP table. So that's the only sort sequence number that you will find in the actual storage bin master data table. I see that EWM reads it from there at some of the spots, but I didn't fully get why SAP designed it that way and why not just kept it in the LAGPS table and reads it from there in the coding. Maybe somebody has a good idea and might want to share it with us here in the video comments below. Then let us proceed with the coding and later also the options to enhance the standard code. I will differentiate here between the putaway process in a non-MFS storage type and the putaway process in a MFS storage type. As that's a parameter and customizing based on the storage type, and EWM has different coding here, different logic for both of them. We will start with the non-MFS one, and up front it's important to understand that even though we are creating the putaway warehouse task with the warehouse process type having the activity PTWI here, we will sort the possible destination storage bins based on CLSP. That's kind of hard-coded. You will never have CLSP in a warehouse process type. You will always have PTWI, but we will still sort the possible destination bins based on CLSP. This is important to understand up front. Don't get confused by that. For the putaway processes, you can always and you should always assign PTWI here. And the spot in the code where we are sorting for non-MFS storage type is the include that I mentioned here, and then the subroutine is called sort empty bins. This is at least true for the empty bin strategy, which I am focusing on here. I have to admit I didn't do the detailed research for addition to stock, and I just assume it's kind of similar. And if you want to debug your addition to stock strategy, I would look here into the stack and put my breakpoints somewhere on a higher level, and you will probably also find a similar logic. So what is EWM doing here? You see that in this subroutine, we first select the activity type for the sortation of the bins, and you see that we have a constant here setting the CLSP determination. So the result of this select, you can see it here on the right, is the value CLSP, and there is no way to select a different one based on the constant here. And with this activity type here, you see it here imported into function model SCWM ACT underscore area underscore evaluate, and within this function module EWM is sorting the bins. This is actually called here in the stack right after EWM standard maybe plus a custom logic, has determined a list, so an internal table of possible destination bins. And this list is here saved in internal table LTLG PLA underscore unsorted. So this is a whole list of bins. Imagine our rack again. It has a couple of empty bins, and all those empty bins are in this internal table now. And within this function module, now EWM is sorting those bins in the unsorted table based on the sequence numbers that we assigned to those storage bins for the activity type CLSP before. And this is the internal table. Here's our activity type, the sort sequence number. EWM sorts the bin, ascending or descending, based on what you defined in customizing, and then returns an internal table with those bins sorted in the correct way. Pretty straightforward here. That's at least what you would think, but I got confused a little bit, and I will explain to you why. You see here in the subroutine sort empty bins, EWM is importing this table ILAGPL, and this imported table already has the field CLSP underscore sort. And then EWM sets the activity and calls this function module here again to sort the bins. And from my perspective, this is not necessary at all, because EWM could have just sorted the bins based on this internal table and then return from the subroutine. So there might be something that I have overseen here in this function module that is somehow manipulating the sorting or so, but from my perspective it would have worked in the same way by just sorting this internal table and then returning from the subroutine without calling the function module. But in case you have a good idea, I'm grateful in case you also write that one into the comments here. And with that, let us look at the MFS storage type, where it actually works kind of like I suggested before. We are calling method detEmptyBin from class CL_core putstra. There's, by the way, another video about all the details about putaway strategy for MFS storage types. I will link it here in case you are interested. But here we are talking about the CLSP sorting, and you see this is also kind of hard-coded here. We have this internal table of possible destination bins, and we just sort it based on the CLSP sort numbers. You have the spots now, in case you need to debug your sorting, bin sorting, you know where to do that. And with that, actually before we come to the options for enhancement, I would like to make a small digression with you and look into the sorting of warehouse tasks within warehouse orders based on the PTWY activity. Because I mentioned that so many times at the beginning of the video, and so many people and so many occasions in the past where I saw people assuming that this activity type would be used for sorting the possible destination bins. But it is in fact used for sorting the task within the warehouse orders when we already have the destination bins. But I don't want to just mention it, I want to show you also how that works in the coding in EWM. And this is also something where I thought you could take some value with you, and I will now explain to you how this is being done. First step, EWM creates warehouse tasks. So we assume now that the sorting of possible destination bins has already happened based on our CLSP sorting. So we know what is the destination bin, and we create the task and save it in table SCWM ORDEM-O. And while this is being done, EWM reads the activity from the warehouse process type. And now, what I just mentioned before, which is not relevant for the determination of the actual destination bin, Now the activity of the warehouse process type comes into the game and helps us to determine the sort sequence number for the pass sequence in the warehouse task itself. And in our example, we are talking about the putaway process. EWM reads the activity from the warehouse process type, then reads the sorting from the bin master data from LAGPS table for this activity, and then writes this sort sequence number in the pass sequence field of the warehouse task record in the ORDIM-O table. This is happening here. So the determination of the sequence number itself is done via LAGPS read single function module. It's being accessed with the storage bin and the activity type, and it returns the LAGPS structure with the sorting number that you can see here. And this is called in the context of the warehouse task creation. And you can see the call stack here with the activity area evaluation function modules. The result of this step is then a warehouse task sitting in the table with open warehouse task having the sort sequence number, and this number is then evaluated again during the warehouse order creation. And this is here done in this include LWHO main F03, and here we have the subroutine WHOTO sort, and you can see here that if no specific sort rule is given by you via customizing, EWM will apply the default sort rules. So for example, for warehouse order creation rules for consolidation group, for instance, it will sort based on the pass sequence. So assuming you have a mixed HU, different products being created in the receiving process, and you now want to put away these different products into a different storage bin in your warehouse. So you start with the mixed HU, and you need to define a sequence now in the warehouse order in which you want to process these tasks for the separate products on your HU. And this is then done based on this pass sequence. So you have 10 different products on your mixed HU, 10 different destination bins, and they are now sorted based on the pass sequence in EWM standard if you do not customize anything else. But you can, of course, also apply your own sorting rules. Here you see the screenshots where this is done in the customizing. And in your own sorting rules, you can then also use the pass sequence, but along with other criteria given for the sort fields themselves. So I hope that makes a little bit clear where the PTWY sorting is actually used. Just imagine your mixed HU with the put-away process and the sorting of the bins within the warehouse order itself. But as I said, this comes into the game when the task is already created and not like the CLSP sorting in the process of task creation. And I'm pretty sure that some of you are confused now. That's why I thought I will come up with a quick summary of all those different things that I explained so far. So if you look at this flowchart that I created here, everything marked in blue is the actual warehouse task creation, and everything marked in green is the warehouse order creation. And as part of the task creation, we have the first step, the determination of the destination bin, and the second step, the enrichment and the saving of the warehouse task data into the database. And in the first step, we do indeed trigger the creation of a put-away task with the activity type PTWY, but the sorting of the possible destination bins, this is done based on CLSP. And once we have decided for one bin based on the sequence, so we take the bin with the smallest sequence number, then we determine the activity from the warehouse process type, which is PTWY here. We read the sequence number from the LAGPS table based on this activity that we took from the warehouse process type. We find the sequence number in the LAGPS table and save it in the pass sequence field of table SCWM ORDIM-O. And this information is then used here in the green part in the warehouse order creation, where we potentially build warehouse orders with multiple put-away tasks in the warehouse order itself. And in order to sort those put-away tasks, then for the optimization of the treble path, for instance, we read this path sequence field from the warehouse task and from the ORDIMO table. That, I hope, makes it clear a little bit. You will find this flowchart here, or this graphic also on my blog. Feel free to download and copy it from there for your studies or for your trainings. With that, as promised, real quick, the options for enhancement. You can, of course, implement the custom sorting based on your project-specific requirements, and that is pretty easy. There is body SUWM X Core PTS filled sort, and you might want to use it for, let's say, sorting based on the content of the HU. This is not available in standard, but you might want to have a different sorting for empty or filled HUs. Let's say you have a storage type where you are also storing empty HUs, so kind of crates or special types of pallets or boxes. And in case they are empty, you want to store them at the back of the AL. In case they are filled, you want to store them at the beginning of the AL, something like that. So if you want to implement such a sorting, you cannot do this with the standard customizing. You might want to implement your own logic, and you can use the body that I just mentioned here. This body offers a spot where you jump in after the standard has sorted the bins based on what I showed you before, and then you can come in here with your Z sorting. So this is the subroutine bin determination 3. Here you see the include, and this is being called here right after the sort empty bin subroutine that I showed you before, where the standard is doing the sorting. You have this internal table here, and this is again then being imported into the interface method of the body, and you can implement your own sorting. And we are here talking about the warehouse task creation, so the enhancement of the bin determination logic based on the CLSP. So based on the CLSP and standard, and based on your logic here with this body, we are not talking about the sorting in the warehouse order itself. I also mentioned that based on the PTWY activity. This is not done here. For this purpose, I already have a different video. So here, the point that I mentioned near the bottom, I will link the video here on the top in the video description. I have a very detailed, extensive video about enhancing the warehouse order creation rules, and there you can also find the one that you use to enhance the sorting in the warehouse order. So this one here is used for the sorting of the bin determination, and there is also an example class, an example implementation of this body where you can get some ideas and some technical hints about how to implement that in a clean way. That's it from my side. I would like to close the video with some remarks that I thought would be helpful, but I didn't know at which spot and which part of the video to mention or include them. But I just wanted to have them in. The first one is that, of course, the sequence number I only implied in case multiple bins with the same, let's say, value exist. So you are usually sorting bins based on the bin type or the storage section and so on and so on. This is defined in customizing in your put-away strategy. And only if you have multiple bins with, let's say, the same HU type, the same section, so the same, let's say, value for put away your HU, only within those bins, EWM is then applying the sort sequence numbers. Because if you have different bins with different HU types, different sections, and your object, your HU to be put away, then of course always try to find the most optimal one. And if only one exists, then we don't need to sort anything. Only if more than one bin with the same value in terms of put-away strategy is there. Second point I like to mention here is that EWM will indeed sort the bins in case you do not define any activity, any sorting for the CLSP activity at all. So you can still do put-away even if you do not do the customizing that I mentioned before. and EWM will just sort the bins based on their names in a ascending way, I think, and you can still do and execute the putaway. Last but not least, SAP also noticed that this topic is a little bit confusing. So there is a note, and I will also link it in the video description. You see the number here, which gives you some information about the usage of the CLSP activity for sorting. But I can promise you that once you have watched this video here till the end, that you have everything that you need and that there is not more details or more information that you can find in this note. Just to mention that it is there, and of course, if you're interested, have a look into what SAP says about this. With that, I'm closing a topic which is a bit confusing, causes lots of misconceptions, but I think once you spend some minutes trying to understand that, it's pretty easy. And I hope that I could reach this objective with this video. Really grateful in case you hit the subscribe button here and maybe also the like button in case you like the video, because this is what motivates me. This is also what helps others to find this channel, find the information, find the blog. And with that, I like to close the video. Thank you for spending time with me and hope to see you back with the next one here on the channel. Bye bye.